So in this video, we'll try to understand how to use the psychrometric chart and how to interpret the various psychrometric processes. So this is the demonstration of psychrometric chart. Dry bulb temperature is taken on x-axis and specific humidity or humidity ratio, which is expressed in terms of kg of water vapor per kg of dry air, is taken on y-axis. These are the relative humidity lines. Vertical lines represent the dry bulb temperature in centigrade, and these horizontal lines will represent the humidity ratio in kg of water vapor or kg of moisture per kg of dry air. These inclined lines indicates the wet bulb temperature of the air. We are having the specific enthalpy scale located at this particular point. So as we have seen, these vertical lines represent the dry bulb temperature lines. Then these are the specific humidity lines or humidity ratio lines, which are horizontal because we have taken the humidity ratio on the y-axis. Now this particular curve is known as the saturation curve, where the relative humidity of the air is 100%. It means that air is 100% saturated and now it is having maximum amount of moisture that it can hold, and it is not able to absorb further moisture in it. Now this particular line indicates 90% relative humidity. It means that the air is 90% saturated and it is having still 10% of ability to absorb moisture in it. Now we know that psychrometry is the branch which deals with determining the thermal properties of the moist air. The various thermal properties of the thermodynamic properties of the moist air are dry bulb temperature, as we have seen earlier, then specific humidity or humidity ratio. Dry bulb temperature is nothing but the temperature of the air measured by the ordinary thermometer. Then humidity ratio is the amount of water vapor that is present per kg of dry air. Now let us see how to determine all those properties if we know any point on the psychrometric chart. So as shown over here, we have taken into consideration the dry bulb temperature of 30 degrees centigrade and relative humidity of 40%. So draw a vertical line from this 30 degrees centigrade till it intersects these 40% relative humidity lines. Now once we know this particular point, we can easily find out the various other thermodynamic properties of the air. So let us see how to find out those properties. Draw the horizontal line. This horizontal line on the y-axis will give you the value of humidity ratio of the air at 30 degrees centigrade dry bulb temperature and 40% relative humidity. Similarly, this horizontal line, it will intersect this saturation curve at this point, and that will give the dew point temperature of the air. Dew point temperature of the air is the temperature at which the first drop of water will condense from the air when it is cooled. Now draw a line parallel to the nearby wet bulb temperature line. So this is the wet bulb temperature line. Draw a line parallel to that. So this is our wet bulb temperature. So that value will be around 20 degrees centigrade, as you can see. So this value of specific humidity will be around 0.0105, and the value of dew point temperature is 15 degrees centigrade. Then value of this wet bulb temperature, as you can read from the diagram, it is 20 degrees centigrade. Now extend this line so that these are the values of specific enthalpy. So what we can say, the specific enthalpy will be around 58 kilojoule per kg of dry air. Now draw a line parallel to these green lines, which will indicate the specific volume line. So as you can see, here the specific volume is 0.85. Here the value of specific volume is 0.9. So our value of this will be around 0.87. So this is our point 1. T1 is known as the dry bulb temperature, that is 30 degrees centigrade. TD1 is known as the dew point temperature, that value which we have obtained is 15 degrees centigrade. Specific humidity is 0.0105, around that particular value. Then enthalpy, specific enthalpy of the air is around 58 kilojoule per kg. And T1 dash is nothing but the wet bulb temperature, and that we have seen that it is 20 degrees centigrade. So in this way we can find out the various thermodynamic properties of the moist air when we know any point on the psychrometric chart. Now let us see what is the meaning of sensible heating process. In case of the sensible heating process, the specific humidity of the air will remain constant and we increase the temperature. For example, in this particular case, the initial dry bulb temperature of the air is 20 degrees centigrade, whereas the final that ideally we require is 40 degrees centigrade. But because of the bypass factor of the heating coil, the temperature that is actually obtained is 35 degrees centigrade. So bypass factor is the factor which will take into consideration all the air will not come in contact with the heating coil. Some part of the air will bypass the heating coil, and therefore instead of having or attaining the temperature of 40 degrees centigrade, the air will attain the temperature of 35 degrees centigrade, because the air which is bypassed will again act as a load on the heated air. So therefore the actual heating process is only from 1 to 2 instead of from 1 to 3. So initial dry bulb temperature is 20, now it is heated to 35 degrees centigrade. Now it is known as the sensible heating process because there is no change in the moisture content. So W1 will remain the same. Now draw the lines of wet bulb temperature from point 1, from point 2 and point 3, and you can read the values of enthalpy from that. So this is T1, T2 and T3. These are the dry bulb temperatures at point 1, 2 and 3. H1, H2 and H3 are the corresponding values of specific enthalpy of moist air. And as we seen earlier that the specific humidity doesn't change, and therefore it is known as the sensible heating process. Now let us define one factor which is known as bypass factor of the air. It is the ratio of the temperature difference which is not achieved. So here this is the temperature difference T3 minus T2 which we have not achieved, divided by the temperature difference which could have been achieved. So it is T3 minus T1. So the thing which we have not obtained divided by the thing which we would have obtained, that ratio in terms of temperature is known as bypass factor. Similar to the sensible heating process, there is a sensible cooling process. As you can see over here, the specific humidity is again remaining constant, and now we are cooling the air from 40 degrees centigrade to 25 degrees centigrade, keeping the specific humidity constant, and therefore it is known as the sensible cooling process. Ideally, we could have obtained 20 degrees centigrade of the air, but because of the bypass factor, we are not able to achieve it. So in this particular case, the bypass factor of the cooling coil is defined as the temperature difference which is not achieved, that is T2 minus T3, divided by the temperature difference which could have been achieved, that is T1 minus T3. Now let us see another process which is known as cooling and dehumidification. So as you can see, at point 1, the dry bulb temperature is nearly around 38 degrees centigrade. At point 2, the temperature is 20 degrees centigrade, and saturation temperature of the air is 15 degrees centigrade. So there is a cooling of the air from 38 degrees centigrade to ideally 15 degrees centigrade, or actually it should be around 20 degrees centigrade. Now from 2, draw a horizontal line till it cuts this vertical line at point A, and from A draw a vertical line up to 1. Now draw the corresponding bed bulb temperature lines. Now this total process can be divided into two parts. One is known as the sensible heating, and another one is known as one is known as sensible heat, and another one is known as latent heat. From 1, draw a horizontal line, so you'll get the value of W1, then this is W2 or WA, and from 3 you'll get the value of W3. Now as you can see, why we are calling this as sensible heat, because if you consider the process A to 2, then in this particular case there is no change in the moisture content of the air. The moisture content at point 2 will be same as the moisture content at point A, and therefore that process is known as the sensible process or sensible cooling process. Whereas from 1 to A, if you consider, in this particular case the tribal temperature remains constant, but there is a change in the specific humidity or moisture content of the air. The moisture content of the air decreases, and therefore it is a dehumidification process. And as the tribal temperature remains constant and there is a change in the specific humidity or moisture content, this part of the process is known as the latent heat process. So the given particular 1 to 2 process can be split into two parts. 1 to A, that is nothing but dehumidification process, and from A to 2, that is nothing but cooling process. So therefore the total process is nothing but it is the cooling and dehumidification process. The sensible heat factor is defined as the ratio of sensible heat divided by the total heat, and total heat is nothing but the combination of sensible heat plus latent heat. So as you can see from the diagram, the sensible heat is nothing but, in this particular case it will be HA minus H2, whereas latent heat is nothing but H1 minus HA. Let us try to understand another process, that is heating and humidification process. Again, it can be split into two parts. One is the sensible heating and another one is the latent heat. So from 1 to A, there is no change in the moisture content, and the temperature increases from T1 to T2, that is from 20 degrees centigrade to nearly around 38 degrees centigrade, and therefore it is known as sensible heating process. Whereas from A to 2, there is an increase in the moisture content of the air from W1 to W2. So it is a latent heat process, keeping the temperature constant. So we know that in case of the latent heat process, temperature remains the constant, but there is change in phase of the working substance. Whereas in case of the sensible heat process, the temperature changes whereas phase remains constant. So in this particular case, sensible heat is nothing but HA minus H1, whereas latent heat is nothing but H2 minus HA. So using this, we can easily find out what is the sensible heat factor for the given particular process. So in this way, we can interpret the various psychrometric processes using psychrometric chart. Thank you very much for watching. Do subscribe to our channel. Thank you very much.